Okay, this is the second video for the Core 2 geometry practice test. You've just done the area and the perimeter of the square. So I am going to show you how to do the volume of the sphere. Volume of the sphere is pretty straightforward. We're basically just using a formula at this point. We don't really have the understanding necessary to understand the volume, to understand the formula, but we can put that formula into practice. So we have a sphere, and we are shown that the radius of the sphere, r, is the radius of the sphere. It's actually the radius of a circle that's drawn around the sphere. Okay. Radius 4/3 times pi r to the third power is our formula, so I write that. And I will plug in my number for radius. The problem though is I have the diameter, so I have to say radius equals diameter divided by 2. Radius equals 3 divided by 2, which is 1.5. I put 1.5, and instead of having the 4/3, I'm going to divide everything by 3. Once again, fractions mean fraction of 4/3 means 4 divided by 3. I could put 4 divided by 3 in the calculator. It helps sometimes to do the division last though. So I'm going to do 4 times pi times 1.5. And I have x to the y, so I can put in like x to the third power. And if you can see, it actually uses a little caret on your school calculators. There's a caret on your school calculators, the little angle triangle without a bottom, to the third power, and then divided by 3. 14.13, and I'm rounding it to the nearest whole number. So 14, and I put 14 in my bubbles. Take 2 minutes, do the volume of your sphere on the practice test. Okay, we've done the sphere. Let's move on to the pyramid. We need to find the volume of our pyramid here. It's a rectangular pyramid. The base has two different sides, 5 and 12, so it's not a square. It is a rectangle, but it comes up to a point, and we're given the height. So if I look at the rectangle, this line is drawn kind of to the center of that, so it's representing that this line is drawn from this plane up to the point. That gives us our height. So we know the two sides of the rectangle, we know the height. We can go to our SAT reference sheet, and we have a pyramid. So we have length, width, and height. And it's basically the same as the volume of a prism, except that part of it's cut away, so I multiply by a third, or as you will see, I'm going to divide by 3. Multiplying by a third is the same as dividing by 3. So I take my formula, volume equals 1/3 LWH. Volume equals length, I'm going to take the longer one. Width is the shorter one. And height is the distance from the base to the point. That is 15. And divide by 3. Instead of multiplying by a third, I divide by 3. B equals 12 times 5 times 15 divided by 3 equals 300. And I don't need to round it because it already has no decimals. It's already to the nearest whole number. So I put in my 300. I bubble the 3. I bubble the 0. And I bubble the 0. 2 minutes. Try the same problem on a similar problem on the practice test. Okay, back to our example test. And we'll go to the level 2 problems. Level 2 problems are a little more challenging. Find the area and perimeter of the trapezoid. So area, first of all, area of a trapezoid, as we did before, I need the base times the average base times the height. So 1/2 times B1 plus B2 times H. I need H here though. Not a problem, I don't have H. But I have a right triangle. Let me give myself as much room as I can. I have a right triangle here. If this is 90 degrees, this has to be 90 degrees. So I have A, B, and C. So I can go to the geometry reference sheet, and they have the Pythagorean theorem. If you have a right triangle, AB, C has to be the hypotenuse. A squared plus B squared is C squared. So I can say or 4 squared plus B squared equals 10 squared. I can do part of that math. 16 plus B equals 100. And I just subtract 16 from both sides. And I've run out of room. So I can say that B equals 100 minus 16, or 84. I'm sorry, B squared. A lot of people make that mistake. Now I have to take the square root of 84. B equals the square root of 84. Or B equals 9.2. But we're rounding to the nearest whole number. So we'll say B equals 9. And, I'm sorry, 9.1. We're not rounding yet. We're not reporting our answer. So I'm going to say actually 9.17. So I maintain some of my accuracy. And now I have my height. So my area equals 1/2 times 15, and the base, the length of the base at the bottom is 15 plus 4, so that's 19, plus 15 times my height, 9.17. My height is the same as my B in the Pythagorean theorem. So now I go to the calculator again. And I've already got the 9.17. So I can take that times the quantity, 19 plus 15. And divide that by 2. Instead of multiplying by 1/2, I divide by 2. 155.8. And now I round that to 156. And I put it in the bubbles. And I will give you 2 minutes to do the area on this problem. Then I will do the perimeter. the perimeter. Perimeter is going to be kind of interesting. I'm actually going to erase part of the work I did with Pythagorean theorem, just so I can give myself more room to work here. Because we really need to look at the figure itself. I'm going to leave the answer, the 1.96, and we'll go back and look at the problem. We said this was 15, because I have a rectangle here. Part of my trapezoid is a rectangle. If this is 15, this is 15. So my total length down here is 15 plus 4, which is 19. And if this is 9.17, because of the Pythagorean theorem, then this has to be 9.17 as well. So when I start adding, I'm going to start at this point, and I'm going to say my perimeter equals 10 plus 15 plus 9.17 plus 15 plus 4, which was 19. So, go to my calculator. 10 plus 15 plus 9.17 plus 19, 53.17. And I round it off to the nearest whole number. 0.1 is less than 0.5, so I go down to 3 instead of going up, and I bubble it in. Two minutes, do the perimeter on the crack test, or perimeter of the trapezoid. got the perimeter and area of our trapezoid done. Got another composite shape over here. Doesn't really have a name. It's really just a strange shape. It's going to be a lot more challenging. So I'm going to start off with that. I'm going to identify some distances. Actually, I'm going to cut it into pieces that I can calculate. So first of all, I'm going to cut out a triangle here. I'm going to do that area separately. And I will eventually need to find the hypotenuse of that triangle. But that's going to be for the perimeter, so I'll save that. Right now I want to do the area. And I've got rectangles. Here I have a length and a width for this rectangle. I can say A equals 17 times 22. And I have another rectangle over here with the width 22, but I need the length. So I start looking around. I have 38 here. This distance is 38. And this distance is 17. So if I look at my rectangle here, that tells me this has to be 17 along here. So I can say this is 38 minus 17, or 21. So now I have the length and the width of this rectangle. I need to find the sides of my triangle. So I look at what I have here. This side is 22. This side has to be 22. So to find the side of the triangle, I have to take 22 and subtract 12 and subtract 6. So 22 minus 12 minus 6. 22 minus 12 gives me 10. 10 minus 6 is 4. So that side of my triangle is 4. I'll have a 4 up here. And I do the same thing for the other side of the triangle. And actually, I'm going to redraw that triangle, giving myself a little more room. So I have 4 here, and 38, and I found this 21. So 21 equals this number plus 6, or this side of the triangle equals 21 minus 6. So 21 minus 6, which equals 15. So I've got the sides of my triangle, and that is a right triangle, so I can do the area of the triangle. I can do the area of the two rectangles. So the first area, A sub 1, is 17 times 22.